Alright, this next problem is one if you had 105 you saw before. It's kind of relating graphs, ordered pairs, and function notation, and it's something that comes up a good bit. So first it says locate the ordered pair 2, -5. So 2, that is my x coordinate, and -5 is my y coordinate. So that means we want to go from the origin 2 to the right and down 5. So this is that point on the coordinate system. And it's asking us to write this ordered pair in function notation. So if you recall, function notation looks like this. F of x is equal to y. So if I have an ordered pair x, y, and I want to write it in function notation, we basically just substitute right into f of x equals y. So this will be f of the x coordinate is 2 equals y, which is -5. So that's how I represent the ordered pair 2, -5 in function notation. For B, this problem says find f of 4. So what that's really asking me is to find an ordered pair that has an x value of 4. And that's because if I look at my function notation, you see that in this problem, the 4 is in the place of the x. So that means in my ordered pair, I know that the x is going to be 4. So if I go over to my coordinate system where x is equal to 4, you go to the graph and you find this point right here, which is 4, -2. So what that means is from this graph, if I have an x value of 4, its corresponding y is -2. So to give that answer in function notation, we just substitute again. That means f of x, which is 4, is equal to y, which is -2. And then for C, this one says find all values of x such that f of x is equal to 2. So what this one is asking is to find all the ordered pairs that have a y value of 2. If you look at the function notation for this one, you notice this time the number that it gave me is in the position of y and we don't know x. So what's different about this one is you have to remember, if we're looking for x as given a y, that most of the time there's going to be more than one, because y equals 2 is actually a horizontal line. So we're going to want any ordered pair along the horizontal line, y equals 2, that touches the given graph. So in this particular case, there's going to be 2 of them. Those ordered pairs are -1, 2 and 5, 2. So if we want to write those in function notation, it'll be f of -1 equals 2 and f of 5 equals 2. Alright, so next we're going to look at some application problems, and these are why we learn to solve polynomial equations by factoring. So this first one says, during a Florence Flamingo baseball game, the mascot uses a powerful slingshot to launch t-shirts into the stands. The height given by h of t in feet of an airborne t-shirt t seconds after being launched can be approximated by this given polynomial function. So after peaking, a t-shirt is caught by a fan 70 feet above the ground, and we're asked how long was the t-shirt in the air before being caught. So with these application problems, what we need to do is figure out what stands for what and what information we're given so we know how to substitute and how to solve. So first, this says the height h of t. So in this equation, the height is given by h of t, and that is in feet. And then it says t seconds. So t is going to be the time that the shirt is in the air in seconds. So what we know is the t-shirt is caught by a fan 70 feet above the ground. So feet is a height. So what that means is the problem is telling me h of t is 70. And it's asking how long, so that means I'm going to solve for t. Alright, so my equation the information that we're given is what h of t is. Now be careful with the notation and what it means. This doesn't say h of 70. It says h of t equals 70. So the entire h of t expression is going to be replaced with that 70. So now the only thing in the equation we don't know is t, and that's what we want because that's what we're trying to find. So you notice what we have now is a polynomial equation. If we want to solve it, we have to be equal to 0. So the first thing I'm going to do is subtract that 70 from both sides so that my equation is equal to 0. So once we're equal to 0, we need to factor it so that we can set the two factors equal to 0 and solve. So you could start by looking at this and saying, well, I've got a trinomial and a is not equal to 1, and look at it as AC method. It would work if you do that, but it's going to be a little tedious because a times c is going to be negative 15 times negative 60. What's always a good idea with these problems, since this is math land, is many times all three terms in these equations will be divisible by that lead coefficient. So that means that we have a GCF of negative 15. So I'm going to start by factoring that out. That leaves me with t squared minus 75 divided by 15 is 5t, and 60 divided by 15 is 4. So now what I need to factor is t squared minus 5t plus 4, and that's a whole lot simpler than the negative 15t squared plus 75t minus 60. So we'll just leave the GCF out front. Now that the A is 1, we know we have to have T and T. C is equal to 4. So my factors are 1 and 4, 2 and 2. And the ones that will give me a -5 are 1 and 4. So I don't know if you remember the lesson from yesterday, I think. Remember we talked about 1 and 4 multiplying to +4, but -1, -4 also would, and -2 times -2 also would. You can probably see why I went back and added those factors, because 1 plus 4 won't be -5, and neither will 2 plus 2, right? So we need the -1 plus the -4. So that means over here we're going to write this as t minus 1, t minus 4 for my factorization. And now we set each of the factors that have a variable term. So the -15 that's out front, that's just a number. It doesn't have a variable, so we don't include it. So we're going to set the first factor t minus 1 equal to 0, and the second factor t minus 4 equal to 0. And then we're just going to solve each one of those out. Now both of these came out to be positive numbers, so that doesn't let me exclude one just from looking at the potential answers. So we kind of have to think about what the question is asking here for a minute. It says, after peaking, the t-shirt is caught. So we'll learn more about this later, but when we have a quadratic or squared term in a function like we do here, the motion that it takes is a parabola. So you can think of the person standing here and he shoots off the t-shirt, and then at some time t equals 1, it reaches 70 feet the first time. Then it's going to peak at the highest point, and then it's going to start coming down, and when it's at 70 feet again, that's where the t equals to 4 seconds. So our question is asking us for the after peak time, so that means it's going to be this one. So for how long was the t-shirt in the air before being caught? It was in the air for 4 seconds.